Here's our bad physics and Flash games. We did Donkey Kong Flash game. My name is Brendan Ramsey. And this is
Nathan Lovingood.
About the game. The general purpose of the game is to, of course, have fun. Don't take into account the physics, but this is physics class, so this is not our case. The purpose of the game is to play as Mario to save Princess Peach from Donkey Kong. I'm sure y'all have played this game once time in your life. If you haven't, you have no childhood. What to avoid is the barrels. If you get hit by a barrel, you lose. The force is too strong for little Mario. Little flame guy. At the beginning, most people don't notice this, but at the corner is a little flame guy moving at the slowest rate possible, but he also can hurt you. He's a little fireball. What to aim for? The ladders, they help you move from the next level, get up higher to save beautiful Princess Peach. And also you want to jump over the barrels because you don't want to get hit. This is a demonstration of the game right here.
Alright, so this is the link to the game. It's kind of nice, it doesn't have any advertisements on it. But Donkey Kong's got Princess Peach, and you can see he's making all a bunch of different ramps. So the goal of the game is you have to try to get to the top. This game isn't like the original, it actually loops. Now pay attention to the bottom. As you can see, there's a little flame guy you want to avoid. Just climb up the ladder, and also take into account, notice that the barrels are rolling. They're not accelerating down the ramps, they're actually going up. At least, I'm actually really bad at this game. But they have no acceleration when they actually go down. So, but it's a really fun game though.
Alright, the controls you want to use is the space bar to jump, the up arrow to climb the ladders, left arrow to move left, right arrow to move right. The tips that you want to consider that when you're playing the game, the barrels will go down the ladders and skip ramps. You don't want to go up the broken ladders, they just get you stuck there. And do not stay in one point because the barrels just change direction and clearly it's a ghost in the game.
Alright, so we're able to reference back later to Newton's laws. I just made a table stating Newton's laws. His first one is an object at rest tends to stay at rest. An object in motion tends to stay in motion at a constant velocity, and both are unless acted upon by an outside force. The second one is force equals mass of an object times its acceleration. And Newton's third law is for every action there is an equal and opposite reaction. Alright, so when we were playing the game, we took into account the different aspects of it, and we found 4 different qualitative observations. We made 2 that we thought were good with physics and 2 that we thought were bad. And they kind of contradicted themselves also. There's just one specifically that does that. Start off with one that agrees with physics is using Newton's second law of force of an object equals its mass times acceleration. You'd be able to, doing the proper measurements, you'd be able to figure out how hard Mario gets hit with the barrel if he wants. So like, he's jumping up, and if he tries to jump or he doesn't jump and he gets hit by a barrel, you can calculate the force which he gets hit by. The second one is, as stated previously, the barrels don't have any acceleration. They stay at a constant velocity, but they don't stop moving. So an object in motion tends to stay in motion at a constant velocity unless acted upon by an outside force. As they go down the ramp, they don't accelerate, they just stay at the same speed. This kind of contradicts with this top one up here. One that's really bad and disagrees with physics is the barrels don't accelerate as they go down the ramps. Using the acceleration of an object as it goes down a ramp is equal to gravity times sine of theta, which is the angle of the ramp. You should be able to figure out, it has an acceleration because gravity is also involved, and it's kind of acting as an outside force, so it should be accelerating. And the barrels just randomly change direction, which there's really nothing to explain why. They can just randomly, as they're going down the ramp, all of a sudden they just turn direction and go down a ladder, or they'll just go and then just at random points in time, they'll sometimes just turn and just go right off the ramp, not even down the ladder. And there's no outside force, no real outside force, like pushing the barrels in the changing direction.
Here's our quantitative observations to prove that what we're saying is not just BS. So what we did is to find on the knowns on the right-hand side, theta equals 5 degrees. We took a protractor to the screen, and when we did, we measured the angle, and the angle of the ramp was 5 degrees. We researched the mass of the barrel, assuming that the barrel was filled with flour. It was 89 kilograms. Gravity is 9.8 meters per second. It's found in the book. It's in physics class. It should be grounded in our heads by now. To measure the time, we took it from the barrel at the top of the ramp all the way to the bottom of the ramp without a change in direction. As we timed this, it came out to be 3.5 seconds. VI is 0, assuming that it starts from the top of the ramp and it changed direction. And acceleration 0.85 meters per second squared. How do we find that? Look to the left. We started with the acceleration g sine theta equation. Acceleration 9.8 times degrees sine 5 degrees, and we got it to be 0.85 meters per second squared. Force equals mass times acceleration. The 89 kilograms times the 0.85 acceleration that we found before to get it to be 76 newtons. This is just some information that we wanted to find to see how hard Mario got hit. But we really wanted to compare between the game and reality is the final velocity of the barrel at the end of the ramp. So to do it in the game, we use the first kinematic equation, I believe. VI is 0, cross that out. The acceleration from the top equation times 3.5 seconds. We got the final velocity to be 3.0 meters per second. Some more calculations, yay. To the right, we measured the ramp out with a ruler. We got it to be 8.5 centimeters. We also measured Mario as respect to the ramp. It's 0.50 centimeters. So what allowed us to make a scale or proportion is we researched the average height of an Italian man, 67 inches, and then, yes, Mario. He's Italian. So we set up the scale, and we got it to be 95 feet, and converted that to meters is 29.2 meters. So then to follow what the reality standards were, we used another kinematics equation, and we got this one to be 7.0 meters per second. That's a big gap from the game.
Alright, so comparing what the final velocity was in the game compared to what it is or what it should be in reality, taking the percent error, we calculated that it was 57%, which is bad. It's failing, it's really bad. And then we also did percent difference, so we just kind of looked at both of them, and the percent difference on would end up being 80%, which is also really bad. And as you can tell, Donkey Kong's not very happy with that. He doesn't like bad physics. So now, is this good physics or bad physics? The game, the final velocity as a result of the game ended up being 3 meters per second. In reality, it should be about 7 meters per second. With the 57% error and the 80% difference, it's kind of bad. So we kind of say it's bad physics, and the people didn't really take into consideration that much physics. And according to our qualitative observations, the Newton's first and second laws were both violated decently. But it doesn't detract from the game. It kind of depends on the way you look at it. If you want to be all technical about it, yes, you can, because as the barrels accelerate, you have to adjust your timing as far as you want to jump over, like probably a little sooner, because it'll get to you a lot faster than when it's just going down in a constant velocity. At different points of the ramp, I guess it depends, but it'd make it harder to jump over. But at the same time, if you're not really that picky about it, you just want to play for fun, then it doesn't really detract from the game, because it's a lot of fun to play either way.
Sorry. Questions?
All right, let's thank our speakers. All right, questions? Almost there.
Just kind of like, I know you guys didn't cover this, but it's like another qualitative thing, I guess. Did you guys like look at how it went, the barrels just would go down the ladders at all? Like,
Oh, how they change direction?
Yeah.
Yeah.
Those, we assumed that if they were to have an acceleration, it was just assumed that they would have an acceleration. That's what the game standards would be.
Yeah.
But yeah, the barrels basically, once Donkey Kong threw them, they stayed at whatever speed that they were. But assuming that they were to have an acceleration, it was roughly about 0.85 meters per second squared.
Thinking back to the proportion that you guys used, and correct me if I'm wrong, but was Mario really half of a centimeter tall?
Yeah.
That seemed like really tiny.
Yeah.
Yeah.
The game is, you see Mario, he's like this big, and then you got Donkey Kong, he's like this big, and the ramps are this long. So I don't know, he's on a different planet in a big world by himself.
I can't imagine how big Donkey Kong is. Figure that one out. It's like King Kong.
All right, let's thank our speakers one more time. Nice job, everyone.
Good job.
Congratulations. By congratulations, I mean it's over.